Hello students, today we will move on to look at the second presentation on places to work with regard to high-tech architecture or high-tech buildings. And as I was telling you earlier also, and you will see particularly in this presentation, how high-tech buildings moved away from just being more of a style to becoming more of substance. Last time we had seen these buildings. I had talked to you about the Commerce Bank, the first ecological skyscraper. I had talked to you about the Swiss Re, also by Norman Foster, another ecological skyscraper, very similar in its concept to the Commerce Bank. We talked about the HSBC, which was an exoskeleton and had very interesting technological features. Sainsbury had amazing technological features for its time. So we realized through these projects that they're all high tech in technology, and these were iconic buildings and they were trendsetters. And there are different points of focus now within the high tech. So we find that initially when we talk about the Centre Pompidou or the Lloyds of London with services being outside and completely exposed, those kind of buildings were generally not repeated. The concept of inside out continued to remain predominantly in the works of Richard Rogers, and I had shown that to you in a slide in the last presentation. But even then the outside services were behind a glass wall. So let's talk about a few buildings of Richard Rogers and consider how the inside out concept and the flexible interior space concept now became a slightly more different and more polished as compared to the more raw Lloyds of London. In the 88 Wood Street building in London, Richard Rogers did this building. I have also talked about this building in my lecture number 46 and 47, so you can find more details about this building in those slides. But here I'll again try to collate the information and tell you about this building. This building also has cross bracing, which is one of the features of high-tech aesthetic, and it is the second Richard Rogers building that was built in London after the Lloyds of London. He refined corporate, this is the refined corporate phase of high-tech architecture, less raw than the Lloyds of London, with services integrated behind sleek glass facades. Even Rogers never tried Lloyds again, and that radical form of high-tech architecture did not appear in his later buildings. This is how the 88 Wood Street building has been placed in the urban context, and I am sharing this or making this point here that about its placement in the urban fabric for a reason. You see, these buildings that were designed by high-tech architects were so radically different from their surrounding environment that it was not that they did not make an effort to fit their building into the urban context. We have seen that in the case of Lloyds of London also, if you will go back to that presentation, how they have tried to correlate the building with the surrounding urban scape. Here also they have tried to do that. This building is a 33,000 square meter building in 3 linked blocks, number 1, number 2 and number 3, and the blocks step up from 8 to 14 to 18 stories in height with service towers placed in between them. Each opens out onto a roof into a sky garden with views of London. So you get these roofs and they are like sky gardens with views of London. So this step up that happens from 8 to 14 to 18 stories is actually in response to its urban context. It is an attempt by Richard Rogers again, as he did in Lloyds, to try to fit the building in the urban context. The very next building that I will show you, the Lloyd's Register of Shipping, you will understand how much more effort Rogers makes to fit the building in the context, though the building is completely different from the surrounding urban scape. Now again, like in Lloyd's, which had a tight site and the whole building had to be fit into that, you see here a similar thing happens in the 88 Wood Street also, making the best use of an irregular and a tight site, and it is positioned parallelly to the Wood Street. Thus it acknowledges the historic street pattern and adjusts the building to the irregular shape of the site, just as he had done that earlier in the case of Lloyds of London. But one difference that you will find, I'll show you that whereas these 6 service blocks are very much plugged in or clipped on from the outside like this, and there are these service blocks of 88 Wood Street which is also plugged in from outside, but the way that they are placed in 88 Wood Street, they seem to actually hide more and are not that much obvious or in the face. I'll explain that to you in a little while later. So this stacked arrangement allows the buildings to be easily divided into smaller flexible tenancies as required, and we'll see that in the plan. Here it is. Now there are number of setbacks which is an additional benefit because there are a greater number of corner offices. Because of the setbacks provided, all these places can have more number of corner offices, and in most cases they have view to the outside and daylight can penetrate into the building. So the design of the building is such, and especially this is valuable in the London rental market, that there are more corner offices available and there is this unimpeded view of the city. Though the basic layout is that there are these 3 blocks, each is 18 meters deep and each is varying in length, 3 different lengths are there, and they are all parallel to the Wood Street. Now both buildings, the perimeter services are there. So we have the perimeter services in Lloyd's, and here also the perimeter services. So this was the point I was trying to make. When you see these 6 wings, these 6 service cores, they are on the outside of the building, attached to the building, very obvious. In the 88 Wood Street, an attempt has been made to somehow fix these or clip these cores in a manner that they are not so outwardly obvious as in the Lloyd's of London. They are more cohesively integrated into the Wood Street building, and then I'll show you the pictures also, you will understand this. So here in the 88 Wood, so the other thing is that because the service cores in both the buildings is on the outside, just as there was an Omniplatz in the Lloyd's of London, this space also becomes an Omniplatz, a serviced zone. In 88 Wood Street, there is maximum flexibility in planning as in other high-tech buildings. There are 3 blocks separated by these 10-meter gaps, which house the service cores, that is the stairs, lifts, toilets, the mechanical electrical services, and because of this niche in which the service core has been established, like I said, it is not so much on the outside like in the case of Lloyd's. The floor plates are adaptable for either a single headquartered tenant, or it can be subdivided into 3 tenancies. So for example, it is quite possible to divide the building into 3 different tenants, each having access to the service core, to the washrooms, the staircase and the elevators, etc. So this again is an example of inside out with perimeter services, but it is much more refined and elegant and a solution as compared to the Lloyd's of London. Architectural expression, the service cores are encased in slender glass towers at the corners. High-tech idea of making services readable but more refined corporate aesthetic has been used here. So the same high-tech idea of keeping these elements on the outside and making them to be readable, but here it is behind the glass, much more refined. Thus as compared to the raw ducts we saw in the Lloyd's of London. Then there is this transparent light cores. Each of the cores that you see, 1, 2, 3, 4, 5 and 6 cores are there. Each of the cores are transparent and light cores that allow for light and views. There is a certain glass used in this building called diamond glass by Saint Gobain, which is a kind of, you can call it a super white glass. So these cores are placed at the sides of the building in that 10-meter gap, and they maximize daylight and outward views because they are so transparent that, say for example, you are standing here and you look through the core, yet you can see through and through. Everything is completely transparent. This is the corridor leading down towards the elevators. This picture that you see here has been taken from somewhere here, and it is showing you this core, and it is showing you this passage leading down to the elevators, and then there is no bulky obstruction in the workspaces by these cores. So two things are happening. The bulky obstruction is not happening because they are placed outside the work area, and it is not happening visually also because it is so transparent. So these cores are transparent and discrete. These are views of reception foyers, and what I did was I tried to compare the foyer of Wood Street with other such iconic buildings. So if this is that of 88 Wood Street, this is also 88 Wood Street, but this is the plaza of HSBC, this is the foyer of Seagram, and this is the atrium on the ground floor of the Lloyds of London. So just thought to see how these spaces compare with one another. Now the 88 Wood Street building has a double height entry and main reception area which is accessed 1 meter above the ground level. Now this is a very small but an interesting fact, because they have done it because they are clearing the telecom exchange infrastructure which is cutting through the full length of the site. So in order to not damage that, they have raised the building 1 meter above the ground level, and the building design also has been done in a manner as to cause no damage to the infrastructure. Then the use of bright flat coloring. Yes, even in Wood Street it is there. There are exposed ventilation funnels on the London wall, and they are primary colors used in them, blue and red for example. Just like the use of primary colors in Pompidou. For example, the ventilation funnels in Pompidou were in white. There is transparency, layering and movement, one of the six aesthetic rules of the high-tech building. It is here in this building by Rogers. Because of extensive use of glass, we find that there is a layering of ducts, then stairs, and then the structure which is inside, the served area which is inside. So the building shows itself to us through the glass via these layers. Secondly, the aspect of movement, the transparency aspect of movement is that there is a visual emphasis. You can actually see the staircase and the elevators. They are not hidden from you, only that they are behind the glass. So the structural members are also exposed inside as element of the building's aesthetic. This is one such example, and it is other such members are also visible in the building. The building uses a triple glass facade with automated blinds that controls glare, stores solar heat by day and releases it at night. Therefore, it becomes a true high-tech environmental system. With regard to this and more details about this automation system, please go back to my earlier presentations either in lecture 46 or 47, where I have talked about this aspect of the 88 Wood Street building. I have also talked about this aspect about the day lighting and the views outside, but I will reinforce that again. Due to transparency, daylight, and because the floor plans are shallow, it brings light deep inside the building, reducing the use of artificial lighting. The views are clear outward views from all the workplaces. From all the workplaces, wherever you are in the building, you get very clear views of the outside, and you get a lot of natural light flooding into the building from all sides. This enhances comfort and productivity. The very presence of natural light does it to us humans. The design hallmark of this building is this Richard Rogers humanistic high-tech approach, that he is very much concerned about how the occupants will be benefiting from this building. Will they be comfortable while they use this building? Then comes the Lloyd's Register of Shipping in London. It was actually completed before 88 Wood Street. This was completed in 1999. Wood Street was completed in 2001. Again a glass and steel block, but it's very similar in many ways to the 88 Wood Street building. Only thing is that the extent of glass used here seems to be even much more than what we found in the Wood Street building. The building steps up from 7 to 10 to 14 stories, just like did in Wood Street building, and it has two basements covering a total area. The total area of the building is 24,000 square meters. It's a refined high tech like the Wood Street with sleeker corporate look versus the raw Lloyd's building. The facade has services hidden behind the glass skin. The structure is lightweight exposed steel system. The circulation towers are expressed but integrated with lift and staircases visible as distinct elements but contained within that glass facade, unlike Lloyd's where they are projected on the outside. And when we talk of the glass facade or the glazed facade, they have got transparent curtain walls which reveal all this internal structure and services, a refined version of Lloyd's high-tech vocabulary, and Rogers' vocabulary has evolved in high-tech architecture. In layering, we see the clear separation of structures and services, circulation and workspace visible through the glass. Those layers are visible through the glass. So again, it is Rogers himself. Rogers did Lloyd's, Rogers did these buildings, but we see that he himself has adapted and evolved and understood what works better than what he came up in his initial ideas. The building is now the important part of this building is that it is surrounded by heritage structures. The building is carefully inserted next to a historic building. It's an intentional contrast between glass and steel and lightness and transparency versus heavy opaque stone masonry. On one side there is glass and steel, lightness and transparency, which is of this building that you see here, and on the other side surrounding it is heavy and opaque stone masonry. You can see that even in this model. So context to keep the street, the building designed by Lloyd keeps to the street line and aligns with the neighboring buildings. Again, what is the idea? The idea is to align the building and make it fit into the urban context. That is a very amazing thought process because there is no doubt that the buildings of Rogers are very radical in a very heritage or historical type of urbanscape around him. But even in that, he has in Lloyd's or Wood Street on this building always tried to somehow fit the building into the urban context. And one of the ways he does that is by alignment, as he is doing it here. He also does that by relating heights with the heights. So the height steps down from, or rather it is stepped from 7 to 10 to 14, 7 to 10 to 14 stories, so it does not overpower the nearby historic buildings. In fact, this is the historic building. So he continues this rise from the historic building in a very harmonious way. A smooth height change takes place between the old low rise and the new tall building. The scale transition helps to maintain the urban connectivity with the old buildings. There is a site response also because the site is very irregular. The floor plates taper to fit the irregular sites. You can see all the floor plates, they are tapering to fit the irregular site shaped by the existing buildings on the two sides. Again he is faced with the same problem he was faced earlier, tightness of site, whether it happened in Lloyd's or Wood Street or here. But I feel of the three solutions that he came up with, this solution probably seems to be the most complex of them in the way he has put it together. So here we have the plan, and this also forms when you enter in from this part where the old buildings are there is an old courtyard that has been created which ties the old and the new buildings together. This role of pulling daylight into the new building is done by the courtyard, supported by two more atriums. There is one atrium here which runs through and through, and a smaller atrium in the front of the building. Informal gathering spaces also here for people who are using both these buildings. And in the lower and middle floors, we see, please hear me very carefully so that you can understand. In the lower and middle floors, there are a large central atrium and a small atrium near facade. Here is the large central atrium which is literally going through and through, and a smaller central atrium. The building form is tapered. Now with the courtyard, it brings light deep inside the building. Here we can see, using the courtyard, using the atrium, the light comes deep inside to brighten up the workspaces. But when we go to the upper floors, the atriums do not continue as it is. The atriums actually are roofed over. For the most part, they are roofed over. Floor plates become continuous and efficient because daylight is easier to access at the heights at the upper floor. You do not need the atrium for that, because the upper floors can automatically, because they have risen higher than the surrounding blocks, they can get natural light without the atrium. So there are this being a true high-tech building, and buildings changing from being high-tech in style to high-tech in substance. I will show you some points that is true for a lot of high-tech buildings in the 21st century. First is intelligent facade, advanced environmental glazing to reduce solar gain and improve energy efficiency. The second is a natural ventilation strategy. It includes openable windows and ventilation systems which are integrated into the facade. The third is energy efficiency, which is vital to exceed standard office sustainability norms, anticipating today's environmental high tech, that we should do better than what is prescribed as standard energy efficiency. Integration of services, mechanical, electrical, IT infrastructure becomes a part of architecture, and it is not hidden, and the technology is driving the design, not just the appearance. The technology is not just putting in services and all this just to make the appearance of the building. That is not enough. The very design of the building is being driven by technology. Transparency as democratic tech. Now here the idea is, because the glass skin is there, it is not only an aesthetic but also it shows openness of the institution, and for the workings of the institution is visible to all. We have seen other buildings before, like the Reichstag and the Welsh Parliament, where they did it. And the construction technology is about advanced prefabrication and precision engineered steel components, high tech as process, not just in appearance. The refined evolution of high tech has taken place in the late 1990s. High tech was about pipes on the outside, but high tech now is no longer about pipes on the outside. It is said that the late 1990s it started happening, that pipes on the outside is not true, but smart facades, intelligent climate and system and transparency have taken over. So smart technology, smart construction, energy efficiency, natural ventilation strategies, that is climate responsiveness, all these have now become sacrosanct, or at least important for a high-tech building design. Thus, when we talk about the aesthetic with regard to color, we find Lloyd's register of shipping is silver, grey, steel and glass aesthetic with subtle accents of blue, yellow and red. It is a refined high-tech palette which is very elegant, corporate, very much restrained, not like the bold color coding of the earlier high-tech buildings like the Pompidou. The glass service cores make the lift and stair movement visible and animated on the exterior. So you can see the lifts moving up and down the side of the Lloyd's register of shipping. So Rogers has not given up on that. Some of these principles remain. The core towers are topped with the seal-clad motor rooms which are elegant, functional finish. The building is 30% less energy, 30% less carbon emissions than conventional air-conditioned buildings. It is achieved through reducing the solar heat gain via the facade design. It is through using concrete thermal mass to stabilize the indoor temperature of the building by employing chilled beams instead of the traditional HVAC system. Chilled beams are ceiling mounted cooling systems which use water cooled pipes to absorb the heat from the room and provide very quiet and efficient air conditioning without the traditional ductwork. So that has been employed in the Lloyd's register of shipping. The main point that I am trying to make when I am showing you these buildings and making these points about them is that they have moved on to become smart tech. They are high tech in actual technology. They have lightness and transparency, that is true. So moving from Lloyd's of London, we find greater lightness and transparency in the Wood Street and in the Lloyd's Register of Shipping. When we compare their plans, we know in all of them the services have been clipped on the outside of the building. Same happens here in 88 Wood Street, and the same happens here even in the Lloyd's system. So concept of inside out still remains in the design ideology of Richard Rogers. Then we go to a different architect. Renzo Piano designed the New York Times building in 2007. I have talked about this building before in my earlier lecture, but I like to put it together again so that we can see this ongoing trend in the buildings. Its strong urban presence. Newspaper occupies the newspaper company occupies the lower half of the structure, while the real estate development firm occupies the rest of the space. It's a 6-story base of tower, atrium for shops, and restaurants and auditorium for lectures. The central courtyard is a green space of trees visible from the street and gives a sense of transparency. So we see that in the section here, and there is an auditorium also for small plays and lectures, which we see here, and from the auditorium, behind the auditorium, you can see the green area, you can see the green space inside the building. There is a high-tech sunscreen that Renzo Piano has used, that is, the facade is made up of clear glass curtain wall with an open weave fabric of white ceramic tubes hanging about 61 centimeters away from the facade outside the glass, and this acts as a sunscreen. The tubes do away with the need of having a tinted glass. So this building actually became LEED Gold certified building for its various energy efficiency systems. It had of course the ceramic sunscreen that I have told you, it had a high performance facade, it had state of the art lighting system, and it had rainwater harvesting or rainwater collection system. So all these and several other points put together gave it LEED Gold certification. It has also got cross bracing along with high tech sunscreen, that is a feature of high tech architecture. It has also got lightness and transparency, which is the feature of high tech architecture. And if we move on from here, the plan is a very standard plan. It's around a central core, something which the high tech architect like Rogers does not do. Piano has done it, but it's high tech in its facade engineering and environmental systems. The evolution of the high tech from this exuberant inside out display as we see in Pompidou and Lloyd's has now become a performance driven elegance. We see that in the New York Times building here, we saw that in the Swiss Re, we will see a part of it in the edge that I will show you. The roof garden is protected by extensions of the glass curtain wall above the actual height of the building, and now we will come to the London City Hall. I'm sorry, I'm going a little fast, we are running out of time. In this particular building, it's a public building with offices, shops, cafes and landscape public spaces. This actually is the office space for the Mayor of London and the administrative people, along with it headquarters of the Greater London Authority. The form is like a distinctive bulging glass egg shape, geometrically modified sphere obtained from computer modeling, and it is sustainable. This building is sustainable, virtually non-polluting public building with radical rethinking of architectural form, because it does not have a front or back in the conventional sense. The structure and facade, the steel frame with the curved glass curtain wall facade allows for maximized daylight and provides panoramic views towards the river. So there is transparency and lightness of high-tech design. From the entrance foyer, there is a very gentle helical lamp that allows the visitors to move up through the building. This has the office of the Mayor of London and the assembly members. As I told you, the council chamber is at the base of the building where debates and decisions are done, and the public galleries, which is on the helical ramp, allows the visitors to look down into the chamber. Thus it is designed to symbolize open, transparent government. Have you heard this before? Do you remember these words from before? Yes, you do. I had talked about this when I told you the design of the Reichstag by Norman Foster and the Welsh Parliament by Richard Rogers. Both of them brought in this concept of openness and democracy in their designs. In both cases, people can look down and see their elected members working below. High-rise building height is 45 meters for this building, total of 10 levels, 500-meter helical ramp that runs across these 10 stories. The central atrium connects the spaces. This open, transparent public access, symbol of democratic governance as I told you, and provides view of interior, and the ramp links to all the chambers and offices. Thus there is tremendous sense of sustainable transparency and accessibility in this building. It is a climate responsive design, not just aesthetic. The form is shaped by environmental logic. Norman Foster saw to it, for example, the south facade slopes inward and therefore it becomes self-shading and thus reduces solar gain. The north facade, vertical and glazed, allows maximum diffuse daylight entering in without heat from the north side, because you know that on the north side you get diffuse daylight. There are very shallow floor plates which allow for deep daylight penetration into the building and to the workspaces. Together with these features for low energy use and allow for better indoor thermal comfort, better visual comfort through natural daylight. The spherical form itself minimizes surface area, reducing heat gain and heat loss. Now look at the energy concept. The chamber is oriented due north to minimize the solar impact. There are PV panels or photovoltaic panels to power the borehole pumps, and these are the borehole pumps that are coming from underground. The building form provides self-shading here towards the south side. There are also openable windows for office areas, a concept that here Norman Foster originally applied first in the Commerce Bank and then later in the Swiss Re building. So each level is offset slightly from the one below, hanging over to one side of the building. The result is a slightly curving side and rapidly curving side. All energy saving features as the building is angled to take advantage of the sunlight in winter and avoid it in summer. It's got a range of active passive shading devices as the building leans back, so the four plates step inwards, shading and providing naturally ventilated offices. Building's cooling system utilizes groundwater pumped via the boreholes from the water table. For most years the building can function with no additional heating and in fact ends up saving 25% energy as compared to a typically air conditioned office building. When we come to the later high-tech architects buildings in the 21st century like the Bloomberg European HQ, we will not talk about them in detail, but just a glimpse of them to see what new things have started happening in the what high-tech has resulted in the modern times, in the contemporary times. 3.2 acres full city block with two buildings connected by bridges, the key pedestrian route in the city. On the ground level, it's got restaurants, cafes behind an undulating facade under a covered colonnade, and thus it makes itself to be one with the public, with the people, with the surrounding city. It's a smart facade of bronze skins the building has that allows for natural ventilation, noise and pollution control, and optimization of daylight. Other sustainable features are under what is called as advanced digital environmental systems. It's got these 2.5 million petal-like ceiling panels, which is not only ceiling finish but it also has LED lighting. It is meant for cooling, controlling the acoustics, the sprinklers, all in a single modular system. And then there is the sustainable workplace features. The occupancy and carbon dioxide sensors are tied into the building management system that dynamically controls the airflow, the ventilation, the cooling depending on the occupancy. There is embedded performance and green innovation in the building that results in water conservation, sustainable materials, workplace wellness. The performance certification given by BREEAM, the rating is actually 99.1%, outstanding rating, the highest score ever achieved by any office development. Then we see the 22 Bishopgate by PLP Architecture, 278 meters, 62 stories high. It's a vertical village because the Megatall workspace has a community-like amenities with flexible floors and co-working spaces. That means that they are adaptable, column-free workspaces, adaptable to several office layouts, and the flexibility concept of high tech is applicable here. They also care for the well-being and provide amenities to the workers like bike hub, wellness spaces, and UK's highest public gallery. So you see here that these elevators, and then there is this vast open space around it for the building. Also has digital infrastructure, data driven management system, facade recognition for entry, and app based services. So it has got a smart building system which is AI driven for controlling the heating, the cooling, the lighting, responding to occupants, and daylight for the interior environment. These exposed services are also there. If you look at the roof, the services, the lines are shown exposed as you would find in a high-tech building. Then we come to the Leadenhall building. It is again Rogers concept continues, high-tech inside out. It has got an exoskeletal bracing structural system, external steel mega frame for lateral stability, and because of it, it gets a distinctly sloping profile. The service core is on the outside of the building. All the lifts in the plants you can see here, in the plan you can see here, they are all on the outside, and thus the interior is completely free. Therefore, this is high tech inside out, free office floors, column free, flexible floor plates that allow open plan adaptability. The circulation is on display, is as in other buildings, but through the glass. So you can see through the glass, and through the glass, 26 glass lifts that run externally. It's a visible dynamic feature, and the structure and services form the building's bold industrial aesthetic. This is the area where you go to catch the lift, and it is very similar in the way it has been put as it was in 88 Wood Street. This is a public realm, a big public plaza created at the base of the Leadenhall building. They wanted a 7-story open atrium, therefore it became a public plaza. When we talk of the Edge, which is a very important building to talk about, so I am rushing through it. It is the world's smartest building, designed by PLP architecture. It has got Internet of Things sensors to monitor light, temperature, occupancy, energy use. It's got corporate sustainability. Here the BREEAM sustainability rating is 98.36, but it is beaten by Bloomberg European HQ by Norman Foster, which has got 99.1%. So it is not as sustainable or energy efficient as, for example, the Bloomberg European HQ, but it still is the world's smartest building. It's got smart sensors and an app to help occupants locate, book, and personalize workspaces. So the workspaces are not permanently belonging to you, and you can work in different parts of the building depending on the kind of work you are doing. And so you can have this app to locate the kind of workspace you desire instead of assigning fixed desks to people. The glass atrium pulls in huge amount of natural light. I'm sorry I'm taking long, but I need to rush through it. Energy positive, it uses solar panels and something called aquifer thermal energy storage systems, or ATES, a geothermal system which stores energy in the underground water bearing layer or aquifers. There are 2 underground wells. The cold well is at 6 degrees Celsius, the warm well is at 18 degrees Celsius. So when in the seasonal energy storage, in summer we want cold water, the cold water is pumped up and it is circulated in the building for cooling, and then the hot water is then returned back to the 18 degrees Celsius well. And these arrows are showing you, the red arrow is showing you for hot and blue is showing for cold. In the winter, the warm water is taken from the 18 degrees Celsius warm well and circulated in the building. That water cools down and that cold water is then returned to the 6 degrees Celsius well. And that is how the system keeps on working. If you go back again, you see how these two are, this is red and this is blue, and in summer and winter they circulate the air in the building. and now the system reduces the need for conventional mechanical chillers and boilers. The sustainability impact is such that it cuts energy use by 70% compared to typical offices and greatly reduces carbon emission. In conclusion, about workplaces today, I will say the workplaces of today are more about communities, about blending work, about having wellness, leisure and culture. They are smart and responsive with sensors, building management systems, flexible layouts which make the spaces adaptive to people and not the other way around. Sustainability is at the core of these buildings with green rating systems, energy saving systems like ATAS and smart ceilings that redefine efficiency. Or vertical villages where towers, skyscrapers are as mini cities in the sky. This kind of a concept we see in Commerce Bank also. Experience also matters. In Bloomberg's cultural design, the edges hot desking architecture shapes how we can feel and connect at work. Thus we see that high-tech architecture has evolved tremendously. If we were to bracket these buildings under high-tech as a style, maybe many of them will not fit the category if it is only a style. But the way they function today, these buildings are truly reflecting high technology in substance, in truth embedded. High-tech is embedded in them. Thank you.